Let's look at the first formula of permutation. So there are 2 to 3 different cases. So the first case being all the objects are distinct. For example, I have here selection and then arrangement of this set of things wherein each of this is different. There is no replacement after selection. So to make you guys understand this, we are selecting 3 out of 5. These are all distinct, that they are different, and once selected they can't be used again. Something like this. So once used, we are not replacing it. So this is your selection of things without replacement. And the total number of permutation, we have seen this before. It's 5 into 4 into 3. Right? Now, what we are trying to do here is we are going to derive the formula for this particular case. So we'll start off with, if we have n different things and we are taking r at a time. So the permutation, possible permutation, is given by the formula p n comma r or npr or npr. These are 3 different ways of representing. So your textbook uses the middle one. The formula is n factorial divided by n minus r factorial. Okay, so I will take a set of example and we'll make use of the formula to look at it. So we have seen this before. I'll just play it again. We have 3 objects, n is 3 over here. We are selecting 2. So we have seen this. We'll end up with 6 different ways, right? So basically this is nothing but here n is 3, r is 2, therefore npr or 3p2 is nothing but 3 factorial divided by 3 minus 2 factorial. So basically this is nothing but 3 into 2 into 1 divided by 1 factorial. So basically this is 6 different ways. As simple as that. Okay, so let's take up another example. Again, we have seen this. Picking 2 objects from a set of 4, all the objects are distinct. We have to keep that in mind. So we have 4 different objects. All the 4 are different. We are picking 2 out of 4. That would be a first one, second one, so on and so forth. So we have basically 6 into 2, 12 different ways. Right? So let's look at this. So here we have n is equal to, not 6, sorry, 4. We are selecting 2. So we're going to end up with 4p2 as your formula. So 4 factorial divided by 4 minus 2 factorial. So this would be 4 factorial divided by 2 factorial. And this is nothing but 4 into 3 into 2 factorial divided by 2 factorial. So 2 factorial will get cancelled. And so we have 12. What if we had to select 3 out of 3 and arrange them, remember, right? So here n is equal to 3 and r is also equal to 3. So basically we'll end up with 3p3, which is 3 factorial divided by 3 minus 3 factorial. But 3 minus 3 is 0. What should we do? Well, 0 factorial is nothing but 1. So it's 3 factorial divided by 1. I'm going to write the answer directly, 6. So remember, this is 1. Why is this 1? I'm going to explain in the next video. Okay. So for now, let's look at this. So selecting 3 out of 3, these are the possibilities. right? Selecting and then arranging. There were 3 objects. I selected all of them, basically arranging 3. We have seen this output. Now, a scenario of selecting 4 objects out of 4. So how many different ways can we do it? So you can see that there will be 6 into 4, that is 24 different ways. So that would be our last example. So this is supposed to be actually, just a second. Let me. So we're going to select 4 out of 4. We had how many? 24 different ways, right? You can see it over here. Again, all of these videos, we can find it in your note section. So if you're interested, you can just have a look over there. So n is equal to 4, r is equal to 4. So basically the formula will be 4p4. So 4 factorial divided by 4 minus 4 factorial, that is 0 factorial. So 4 factorial, we know that is 12 divided by 0 factorial, which is 1. So basically this answer is 12. Wait, 4 in, so 24, my bad. Not 12, 24. Again, I'll make you guys understand why is this 1. Right? So now you guys have to pause and write the heading. That's important to understand that we are having distinct object, different objects, and we are not replacing. Once we are selecting, we are not replacing, right? We need to understand that first, and then yes, we need to write all of this.